Good morning, dear students. Let's start here with chapter 10, that is tides and ocean current. And this is the unit we're going to study. This is unit 3, and in this we're going to study about hydrosphere. But this will be only in one chapter. So for the hydrosphere there is only one chapter, and we're going to see about the tides and ocean currents. So first of all, let's see here about the distribution of water and land and water on the earth. And all of you know that land covers about 29.2% part of the earth, while the water, that is ocean, covers about 70.8. So usually in the round figure we used to say, we call it that 29% is covered by the land and about 71% is covered by the ocean. But in this also, if you'll find here in this pie diagram, here this 29.2% of the land, and it is also again is distributed, and you can find 10.3% is covered by the continental mountains. Then the 18.8%, that is the continental platforms. Now continental mountains means the mountains and the hills, mountainous region, and the plateau region, and continental platform, that is the flat region. So in this, all the plain areas, coastal plains or river plains, everything, even the deserts, they are all included in it. But while here, if you see the distribution of ocean, so here 22.1% part of the ocean is usually, you will find the ocean ridges, and this is 3.7%, that is usually is formed by the volcanic islands, island arcs, trenches, submarine, volcanoes, and the hills. Then here 29.8% is the ocean basin, the deep ocean basin, the deepest part where the ocean floor usually is found. Then next is the 3.8% is the continental rise, means where the this is also part of the ocean, but usually a shallower one. And this is 11.4% is continental shelf and slope. Now here, if you find here this continental shelf, it is included here in ocean. You will find here it is included in ocean, right? But again you will see it is colored in yellow color, and that shows that it is also part of land. So why it is? What do you mean by this continental shelf and the slope, which constitute 11.4% of the ocean? So continental shelves actually are the shallowest part of the ocean. Usually we call it sea. If you'll find the India is surrounded by the two sea, Arabian Sea and the Bay of Bengal. There is one more, Andaman Sea is there. Then you know about so many seas like Mediterranean Sea, Red Sea, and so many seas. Now usually the sea actually, it is usually found surrounding the continents, the land. Okay, so these are the shallowest part, and they are, you can say, they joins the ocean, the deep ocean, with the land. In fact, in the ancient time, this usually, when the water was less, so usually this continental shelf were the part of the continent. But as the water rises, as all of you have heard about the ice age, so during the ice age, the large amount of water usually was found in a form of the glaciers there on the land. And this is why the ocean, usually the level of the ocean was very low, and this continental shelf was actually the part of the land. But what happened as the ice age finished and the ice and the glacier, it all melted, so the level has increased, and this shallower part, shallowest region, the low part, that is the continental shelf, it was submerged in the water. Well, so this is just a brief explanation. Now as it is not given in your syllabus, so that's why I'm not explaining it in detail, and for that we don't have the tools also, means the figures and the diagrams also is not given in the book. So now let's move to the distribution of land and water. Well, already we have seen about that water. When we talk about the water constitutes, that is 71% part of the surface of earth. But most of the water usually is found in ocean. But there are some more water bodies, as you can see, like rivers, lake, underground water, and atmospheric water. So even the water is found in a form of humidity, that is the water vapor in the air, and that is called the atmospheric water. So usually about 99% water usually is found in the ocean, but still here this 1% actually, that is not a 1%, but it is more than 1%, is found where? Either in the form of rivers, lake, underground water, and atmospheric water. Now usually this water usually is a fresh water, and that usually is so important for the living beings on the land, because usually the human beings and all, if you find all the animals, they need the fresh water. So fresh water is very, very important for the survival of life on the land. Well, in the ocean, all the sea creature, they can live there in the salty water. Now let's move here to the distribution of land and water. Now let's see here some of the important fact about the land and water. And the first fact you will find here, the arrangement of the land and water, means the continent and the ocean, it is antipodal. Now what do you mean by the antipodal arrangement? Antipodal arrangement means, when, if you know, all of you know that the earth is round, so you will see the globe of the earth, and you will find if there is a one side, if there is a North America, just opposite of North America you will find there is the Indian Ocean. Now the most common this example we can see in this, that in the southern pole, South Pole, if you will find there is one continent, that is Antarctica, and just opposite of Antarctica there is one sea, Arctic Sea. So if you find on the globe, usually if one side there is a land, now there is a big land mass. If you see the Europe and Asia and Africa, they used to form the biggest land mass, because Africa also is connected with the Asia with a very narrow isthmus, narrow land. Well, and it is only separated by the sea, that is Red Sea and Mediterranean Sea. So usually these all three continents, they form the biggest land mass which are joined together, and the just opposite of these three continents you will find the biggest ocean, that is the Pacific Ocean. So this is what actually we call it the antipodal arrangement of the land and water. This is very important. Now usually this is just one explanation, that what do you mean by the antipodal arrangement. Well, now I think most of you have understood this, but there is one more question can be asked, that is, why this antipodal arrangement is found there on the earth? Why this is antipodal arrangement? So we have seen what, but if the question asks why, then what you will write? So usually actually the earth spins rotates on its axis, so we call it spins. Well, now what happens actually, anything you spins on its right, usually if you find, right, so usually there is a, about the centrifugal force, there is a one more force we have studied about the Coriolis force, right? Well, so in all this thing you will find usually they just tells about different things, but one thing is here, if anything is a spin, I can give you one very, very simple example. Usually you have heard about the potter. The potters actually are the people who usually they make the clay pot. Now how they used to make the clay pot? So usually what they do, they put that clay, wet clay on one wheel, and they spins the wheel and they give the shape to any clay pot. That's why you will find all the clay pot, they are very, very round and very perfect shape. How they get this perfect shape? Because they spins the wheel, and continuously they spins the wheel, and then they give the shape, then they forms any small or big, any type of pot, right? Usually you will find most of the pots usually, right, they are round in shape. And how they get this perfect round shape on the wheel? So they use which theory? This theory, that is the theory of centrifugal force. Now how the centrifugal force also actually creates a balance. So when anything is a spin, so usually everything automatically comes there in balance. So the same way as the earth rotates actually, and what happens, everything, usually the land and the water, everything tries to create a balance there on the earth, and this is how actually you will find there is an antipodal arrangement of land and water. Now I hope all of you have understood this thing. Now let's see the second important fact about the distribution of land and water. So we will find here the land masses are narrowest in the southern hemisphere. Means in the southern hemisphere, if you find, southern hemisphere usually has only 19% of land. Now usually all of you know that there is a 71% water and 29% land. But if you find this distribution in the northern and southern hemisphere, it's totally different. In the northern hemisphere, the distribution of land and the water, that is totally different. Now here the land is 61%. How much land? Land is more than the water. Land is 61%, while the water is only 39%. But in the southern hemisphere, if you find, water is 81% and land is only 19%. 19%, right? So this is what it tells about, that the land mass are very narrowest in the southern hemisphere, right? And most of the land, because the large land mass is found, all of the major continents are found in the northern hemisphere, so large number of population lives there in the northern hemisphere. And you will find there everything. The equinox is also named after, or the solstice, summer solstice, or maybe it is winter solstice, or equinoxes, that is the spring equinox or the autumn equinox. They all actually are named after the season which is been experienced by the northern hemisphere. Now these are all things actually already we have seen, solstice and equinox. So I hope you have understood this. So the second fact is the land masses are very narrow in the southern hemisphere, and most of the land is found there in the northern hemisphere. Now next is the third fact is the Antarctic land mass has 3 protruding areas. Protruding areas, what do you mean by this protruding areas? Protruding areas, we usually will find the Antarctica usually is the one continent which is found there in the southern hemisphere, totally in the South Pole. Right? But you will find here there are the 3 areas which is very close to some continent. So there are a very narrow areas, right? One is that extends towards South America. From there, Antarctica is very close. From the southern tip of South America, Antarctica is very close. Another is the Australia, then South Africa, and third one is Australia. So there are the 3 continents from where the Antarctica is very close. First is the closest is the South America, from where Antarctica is very close. Then there is the South Africa and Australia. Now these are the 3 continents. Usually you will find most of the countries, when they start their voyage, first of all they used to go to these countries, and from there actually they start their journey to the Antarctica. Well, so this is some facts we have seen, right, about the distribution of land and water. Now let's move here, and we are going to see about the ocean currents and their circulation, right? So usually if you find, there are the 3 types of movement occurs in the ocean. Now all of you usually know about one thing, that is the sea waves. So in the movies, in the pictures, and those who have visited the coastal areas, you may have seen about the sea waves. So the waves actually comes and it hit the shore. The waves can be small in size, and they can be very high also. There is one more wave we have studied. We have already seen in the previous chapter about the tsunamis. They are very high wave that has been generated because of the earthquake. Well, sea waves usually, tsunami is a different thing, already all of you know. But how the sea wave is generated? Now usually the sea waves actually are a ripple. Now they are caused by the pushing action of the winds. As the wind blows over the surface of water, they push the upper surface and they just forms a ripple. And when these ripples reaches to the coastal area, they just form sometimes into a bigger wave, sometimes simple normal wave, right? Well, so that is the one thing, is the waves. Now second thing is the ocean currents. Now ocean currents are not the waves. When we are talking about the ocean currents are not the waves. Now what do you mean by these ocean currents? Now to explain this ocean current, a very simple method, simple language, we can explain it, that ocean currents are the streams in the oceans. What are the ocean currents? They are the streams, or you can say rivers in the ocean. So there is a stream, means a river is flowing, right? In ocean itself, now you can't see. The water is flowing in the water. Now you can't see with the naked eye. Only any ship or boat actually that is there on that water, it will start moving the same direction. Well, this is how we can come to know that there is a one river or stream is moving there in the ocean. Well, these moving streams or the rivers in the ocean, they are called the ocean currents. Well, now let's see about here that first of all, before we start this ocean current, let me just explain you here what is given in the book. The first thing, the regular movement in the ocean. Now, usually the movement can be of two types, horizontal and vertical. Horizontal means just parallel to the ocean current. Like example, you have seen about the oceans. First of all, sea wave. Second is the ocean current. So they are the horizontal movement. Another movement is there vertical. Now, what is the vertical movement? The rising and sinking of the surface water. Now, what thing you can find? You know, you already have studied about the tides. So what happens in the tides? The water rises and water sinks. So this rising and sinking of the water, that is the tides we will going to see after finishing these ocean currents. Well, now all these movements are caused due to the combined action of two things. First is the density, that is the density of what thing? That is the water. I will discuss afterwards, okay? Then another thing is the winds. Wind is a very important factor, and you can find all the horizontal movement is taken by the winds, right? Now, how the density, let me just give you a brief explanation about density. Now, usually you know about the water when it is warm, hot water or warm water. So what happens? The warm water usually have lower density. But if the water is cold, what happens? The water, it contracts, right? And the cold water usually has a high density. I think all of you understood. Okay, now let's move here. So first of all, now we are going to see about the very important thing, that is the causes of ocean currents. So let's move directly to the causes of ocean currents. Now there are the 5 factors which usually causes the ocean currents. Now what are these 5 factors? The first factor is the planetary winds. Second factor is the variations in sea water temperature. Third factor is the variation in the sea water salinity. Fourth factor which causes ocean current is the rotation of the earth. And the fifth factor is the configuration of coastlines. Now usually already this video is of 18 minutes. I don't want to just exceed it more than 20 minutes because shorter videos are very effective. If the video becomes lengthy, it will be not effective. So from here, the explanation of these 5 causes I will explain you in the next video, next session. So the 2 minutes is left some time, and let me just take the time to just explain it, the movement of ocean water and the ocean current. Okay, so now usually if you'll find here, one thing already we have seen here about the density. This thing I want to just finish it. Density is very, very important, and the density of the sea water depends upon 2 things: temperature and the amount of salt in the water. This is why we will find here the variation in sea water temperature, variation in sea water salinity. Now before I explain these 2 causes, I need to just give you a brief explanation about the density of the water. So here we have seen here the density of the sea water depends upon 2 things, 2 factors. What is that? And that is temperature and the amount of salt in the water. So what happens here? Now usually the density falls. You can see here, density falls when the water is heated. So the warm water usually has low density, as I told you, and the cold water usually has high density. This is why the region in the tropics region, the fresh water usually you will find, the first of all, the tropic region, the water usually has a low density. It is a warmer water. In the polar sea, the water is high density. Well, another thing we have seen here about the amount of salt in the water. If the more amount of salt present in the water, it makes the density of water higher. So usually the fresh water is low density. Fresh water has low density, and if the water is salined, high salinity, that makes the water density of the water high. Now one example I can give you. You may have heard about one sea which is called Dead Sea. It is a very, very small sea situated in the country Israel. And the specialty of this sea is this water, because this sea water, this is very, very small sea, bounded by the land from all sides. You can find it there in the map of Asia. The very brief means very explanatory map of Asia. In that you will have to see the map of Middle East Asia. So in there you will find country Israel, and if you see this country in detail, and there you will see very small sea, Dead Sea. Now this Dead Sea has the highest salinity. Why it has the highest salinity? Because it has the highest amount of salt dissolved in the water, because this sea doesn't have any fresh water source. There is no river drains water there in this sea, right? So this is why this sea water of Dead Sea is very, very high density. This is why the people, when many people they used to go here just for the tourist purpose. So when they dive here, they don't drown. The people, they don't drown. That's why when they automatically they floats over the water. Why? Because the water has highest density. So now next session we will start from I will explain you about the different causes of the ocean currents. So let's finish it here. All the best.